Okay, like I said, big idea that we're going to do is we're going to calculate our trig functions, and we're going to have to be able to use our angles in order to do that. Okay, and then we're going to estimate based upon our radians. All right, so based upon the picture that I already showed you, some simple concepts that we need to understand about standard position is number one is that our vertex will always be at the origin. Okay, so it's always going to be at 0, 0. All right, so what I mean by that is that this will be the y-axis. Okay, and then the second part of our notes is going to be, this is going to be the x-axis. So the vertex of our angle will always be at 0, 0. Okay, that's the very first thing that we have to understand. Okay. Second part is that the initial side, which you see labeled in the picture, will always be the positive side of the horizontal axis. Okay, so the initial side will always be on the right. Okay, it'll always be on the positive side of our graph. All right, and then the third piece of information that you're going to see, especially when we get down to example number 1, is that anytime that you have a positive angle, so like 120 degrees, we go in a counterclockwise direction. Okay, so this angle that you see here, if you notice that it's going in a counterclockwise direction, represents a positive angle, and so therefore a negative angle would be clockwise. And you're going to see that when we go through the example. Okay, so some just basic ideas. And so the very first thing that we're going to have to be able to do is to create our own picture. Okay, so in the first one, I have 2 pi over 3. All right, first thing that I would do is I would probably change that into degrees. And so the reason why I put that on there is a quick little review. How do I change my 2 pi over 3 radians into degrees? What do we do? Yeah.
Times 180 over pi.
All right, he says multiply by 180 over pi. Okay, the pi's cancel, or the 77s cancel. So what is 2 times 180 divided by 3? 60.
120.
How about 60 times 2, or 120 degrees? Okay, all right, so in terms of graphing, okay, all you got to do is simply make an x and y axis. All right, and then reminder that our angle is positive, so we're going to go in a counterclockwise direction, which means that we're going to go up this direction. All right, and so you just basically have to figure out where is the terminal side. The terminal side is where does our angle end? Do we understand that the y-axis up here is at 90 degrees, that half of a circle is 180 degrees, that 270 degrees gets us 3/4 of the way around the circle, and a full circle is 360 degrees. So therefore 120 degrees is between what? What quadrant would it be in?
Quadrant 2.
It'd be in quadrant 2 because it is going to kind of finish right up here 30 degrees beyond the 90 degrees, and so therefore our 120 degree angle looks like this. Okay, questions on that before we go on? Okay, part B, we have negative 2 pi over 3. Well, what would that be in terms of degrees? Negative 120. Very good. All right, so I go and make my axes. Okay, and now the only thing is, because it's negative, I am going to go in a clockwise direction, and so therefore I'm going to go 120 degrees this way, and I'm going to have my angle end like that. So that's negative 120 degrees. Good? All right, see if you can do the 150 then. Check in to see what you were able to come up with. Okay, hopefully you had your X and Y axis. You had an angle that was finishing in the second quadrant, hopefully beyond your 120 degrees, something like this. Okay, and really all I need is these two things. Show me where it's ending, and then show me that that's 150 degrees. Okay? All right, so the last one I kind of left for us to do together, just kind of think about this for a second. You have 420 degrees, but there are only 360 degrees in a circle. So what does that mean?
It does more than one rotation.
It does more than one full rotation. So if you want to figure out where its terminal side is, anytime it's above 360 degrees, just subtract 360 degrees, and that'll tell you where it is going to end. So what's 420 minus 360? 60. Okay, and then what quadrant is 60 degrees in? The first quadrant. So therefore, we know that it is going to end here in the first quadrant at 60 degrees, and it just show me that you're doing a full circle and then coming back around and ending there. Okay, and then that'll give you your 420 degrees. Okay, so it's a full 360 plus 60 more, giving us our 420. Questions with that? Okay, all right, second part of this, okay? We've got our trigonometric functions that we're gonna focus on. All right, so the big thing there that you need to know is your sine, cosine, tangent, secant, cosecant, and cotangent. All right, a couple of things to kind of help you out is understand that your tangent and your cotangent, if you pay attention to those two, are reciprocals of each other. They always flip. Okay, your cosine and your secant are reciprocals of each other, and then your sine and your cosecant are reciprocals of each other. So that's just simple things to remember. What do I use in order to help myself remember that cosecant is the reciprocal of sine? Well, I just always remember that S and S don't go together, C and C don't go together. So S for sine has to go with C cosecant. An S goes with a C and an S goes with a C. So it's just a little thing, but it helps me remember which one goes with which. Okay? All right? Second thing that you have to understand is if you can remember the ones on the left, the others, you know, we just said are all the reciprocals. Understand that cosine is your x value, sine is your y value, and then tangent is your y over your x. Now, when I go to write it, I'm actually going to do it different than the way they have presented it. I'm going to do sine first, then cosine, then tangent. And the reason I'm going to do that is because then I have my y over my x already set up. And you probably know that big mnemonic device. What's the mnemonic device that we're later on going to use to remember our sine, cosine, tangent? SOHCAHTOA. So you guys already know it as sine first, then cosine, then tangent. Okay, so just reminders there. Okay? All right, big idea that we need to understand is number one, okay, that our radius is equal to 1 all the time. Okay, so we call this the unit circle. Okay, unit for radius being 1. Okay, and then when they talk about theta, okay, that means they want to make sure you understand you're trying to find where the terminal side intersects the circle. Because that is important, because that gives us our x value and our y value. Okay. as you can see here, okay, they gave us P, the point P being x comma y up there, all right? Big idea is that the x value of that point becomes our cosine, the y value of that point becomes our sine, and then we can figure out tangent from that. Okay, the other thing that you always have to keep in mind is pay attention to your positives and negatives, and that's going to be important when we get to some of the later questions, okay? All right, so the next part that we're going to do is going to take into our drawing, and we're going to apply this concept, and we're going to put the two together, okay? And we're going to start with basic ones. We're going to start with very simple ones in which your points are always going to finish on the x and y axis, okay? So, what I mean by that, why does it make it basic, is can anybody tell me what point this is? This point that I just drew right there.
0 pi.
Oh, all right, so we said, I heard 0 pi, I heard 1, 0, 0, 1. Anybody else? All right, it's 1 comma 0. Okay, your radius is 1, so you're going out 1, you're going up none. Okay? Now, what would give me a theta that would get me to that point? What would be a possible angle measure? 0 and 360, 720, 1080, you know, any of those possible angle measures would have my terminal side end there, okay? So you have to understand that we're going to start with our concept of the unit circle and using our radius as 1 to figure out our points, okay? So if we go to example number 2, all right, we are going to write all 6 trig functions. One of the first things that I would suggest doing, it might help you, is maybe just draw a quick little picture, okay? You've got your unit circle here. So I'm just going to draw a circle with the center of the circle at the origin. All right. So if I wanted to have my theta be negative pi, where would negative pi end? Where would the terminal side be? How would you draw negative pi? If you need to, convert it in degrees. What's negative pi in terms of degrees? 180 degrees, so this is the same thing as negative 180 degrees. Okay, remember that you could take negative pi and multiply by 180 over pi. The pi's cancel, and you get negative 180. All right, so that means negative 180 is going to be right here, so it's going to end right there. All right, so we said on the previous side, the most important part is the point where that terminal side intersects the circle. So what point is this? I heard negative 1 comma 0. Do you agree with that?
Yes.
Okay, understanding that the radius is 1 and we're going basically from the origin left 1 and not going up at all. All right, so our 6 trig functions. I am going to do sine first. I just like to do that first. Okay. Then cosine, okay, then tangent. All right, sine is which value, the x or the y? The y. So what's the y value at negative 1 comma 0? 0. So sine of negative pi is equal to 0. Okay? Cosine is your x value. So what is the x value at our point? Negative 1. Okay? And then tangent is your sine over your cosine or your y over your x. So what is 0 divided by negative 1 the same thing as? 0. Okay? All right. So the other 3, reminder, are always going to be your reciprocals. So you've got your cosecant. So what's the reciprocal of 0? Give you a hint. It's not a number. It's not a number. Undefined. Because remember that this 0 divided by 1 would then turn into 1 divided by 0. which would be undefined. All right? Then you've got secant. What's the reciprocal of negative 1? I heard positive 1 and negative 1. Well, here, let's do this. If I take negative 1 over 1 and flip it and get 1 over negative 1, what is that? Positive or negative? Still negative. Remember, reciprocals won't change their positive and negative value. Okay? And then cotangent of negative pi is equal to, I heard undefined, and that is correct. Okay? Negative 1 divided by 0 will become undefined. All right? So, if you understand these three, remember these we can get by doing the reciprocals. You got to make sure you get these three correctly. So know that sine is your y. And again, I set it up this way, sine first, cosine second, tangent for SOHCAHTOA, but also now I just know 0 over negative 1 when I get to my tangent, okay? So it's already kind of set up there for when I go to do my tangent, okay? All right, we'll do another one together, and then I'll see if you can do the other one, all right? All right, part B. First thing that we're going to do is draw our little picture. All right, pi over 2 is the same thing as what angle, if we need it in terms of degrees? What is it? 90 degrees. Okay, if you need to, do your, 180 over pi in order to convert. Okay, so we've got our circle, and pi over 2 is going to end right there on the y-axis. So the big question is, what is the point at which the terminal side meets the circle? 0, 1. Remember that the x value is 0, it's going straight up, it's just 1. All right, so sine of pi over 2. Anybody? What? 1. It's your y value. Cosine of pi over 2. 0. It's your x value. Tangent of pi over 2. It's 1 over 0, not possible, which we're going to say is undefined. Okay? Cosecant of pi over 2. What's the reciprocal of 1? 1. Secant of pi over 2. What's the reciprocal of 0? Undefined. Cotangent of pi over 2. What's the reciprocal of undefined? 0. You see that above. Okay? When cosine went to undefined, okay, well now undefined should go to 0. Okay? All right. Try C on your own, and if you feel pretty good about that one, then we'll skip D. Okay? All right, let's check these. We'll get different people. So, Carol, sine of negative 90 degrees. Negative 1. Everybody good with that? Okay. Dale, cosine of negative 90 degrees. 0. And tangent of negative 90 degrees. Christian. All right. 3 for 3. Love it. So, Anna, cosecant of negative 90 degrees. Negative 1, because that's the reciprocal of negative 1. Mackenzie, secant. Undefined. That's the reciprocal of 0. And Ashley, the last one, cotangent. 0. Everybody good? All right. Sounds like you got it. So we won't worry about D. We'll go on to the next example. Okay. All right. So down here at the bottom, it goes back to our concept of the unit circle. So the very first thing it says to do is just verify that our point is basically on this unit circle. And the way that we do that is, if you remember our equation for a circle, x squared plus y squared is equal to 1. Since our x value is a negative 2/3, I'm just going to plug in negative 2/3 in for x and square. I'm going to plug in root 5 over 3 for my y value and square, and see if it equals 1. So, can anybody tell me what negative 2/3 squared is? three things you gotta remember to do. Number one, square the negative. A negative squared does something. Square the 2 and square the 3. Positive 4/9. Love it. Okay? Can anybody square the root 5 over 3? 5/3, or 5/9, sorry, 5/9 is equal to 1. So is 4/9 plus 5/9 equal to 1? Yes. Check. Okay? So we just verified it worked. All right? Part B is we have to come up with our 6 trig values based upon the concept that we just used above. Okay? So sine of theta, since they didn't give us an actual angle measure, we'll just use theta, is equal to what? Why is it root 5 over 3? Because that's the y value. Excellent. All right? Cosine of theta is equal to negative 2 over 3, and why is that? Love it. Okay? So now we get to the tricky question, tangent of theta. Yeah?
Do you divide the sine by the cosine, but then reciprocate?
Yep. Do you know what that's going to end up finishing up to be?
It's not.
Okay, so he said we should do 5 or root 5 over 3 divided by negative 2 over 3. And that's the same thing as multiplying by negative 3 over 2. The 3's cancel, and so therefore we get what?
Negative 2 root 5.
Negative root 5 over 2.
Yes, that's what I said.
Okay, that's what I thought you said. Okay? Just a hint, anytime the denominators are always going to be the same in sine and cosine, it'll always just be the numerator divided by the numerator. Okay? Just because the denominators are going to cancel out when you flip. Okay? All right, so now we go and do our reciprocals. So cosecant of theta is equal to what? There's something that we're going to have to remember to do.
Negative 3 root 5.
Why did you change it from a positive to a negative?
Because reciprocals are negative opposite.
You're thinking of perpendicular lines.
Really?
Yep, reciprocals we just flip. The sign stays the same.
So it would just be 3 over root 5.
All right, but are we allowed to have a root 5 in the denominator? So what do we got to do?
Multiply both by sine squared.
Okay, so we have to rationalize. And we get
3 root 5 over 5.
3 root 5 over 5. All right, and then for our secant of theta, this one at least we don't have to rationalize. Negative 3 over 2. Okay, and then cotangent of theta, we are going to have to rationalize because we got to flip our negative root 5 over 2. Anybody got a final answer on that one?
2 root 5 over 5.
How about negative 2 root, or,
Yeah, that's
yeah, negative 2 root 5 over 5, okay? All right, so this is what we're eventually getting to, okay, except we're going to do it with 120 degrees and 2 pi over 3, etc., where we have to be able to find these points, and then we're going to do that using our SOHCAHTOA, okay, and that's going to involve our 30, 60, 90, 45, 45, 90. So right now, we're just learning the basic skills to kind of build up to that, okay? On this last page, this deals with our concept of radians and just being able to just use our kind of mental math here and just be able to estimate certain values, okay? Understand concepts in terms of, you know, knowing that sine is the y value and cosine is the x value, etc., okay? Reminder that these represent radians. Remember, a radian is basically take one of these radii and then put it on the circle. So from here to here is one radius, a second radius, a third radius, a fourth, fifth, sixth, and it's just a little bit beyond 6 because 1 pi is 3.1, 2 pi is 6.2. So notice it's roughly 6.2 around the circle, okay? 2 pi being 360 degrees. All right, so sine of 3, okay? Well, you just have to understand that when they say a question like this, that you're talking about a point that is finishing right there, okay? Sine, is that X or Y? Y. So think about this Y value right here, okay? So you're talking about a situation in which your terminal angle does this, creating this point right there. And your Y value is the up and down value, okay? Now, the actual value, they don't want you to figure out. They just want to know, is it positive or negative? So is your Y value, since our terminal side is in the second quadrant, positive in the second quadrant or negative in the second quadrant? Positive. Okay? So cosine of 3. It's not 0. It's negative. In the second quadrant, your X value is negative, and so your cosine of 3 is going to be negative. All right. Think about this for a second. Your tangent of 3. Why is it negative? Positive over a negative, okay, gives us a negative, okay? Understand that idea? Okay, because then we're gonna, yes?
How'd you get the cosine?
Okay, so when we get to, going back to our picture, okay? Remember that we're talking essentially about this point right here, right? Okay, so our cosine is the X value that gets us out to that point. The Y value is the point that gets us up to that point, right? And that's gonna create our actual point, okay? Our X and our Y. So notice that we're going left along the X-axis, so that's negative, right? And then we're going up, so that's positive. We don't have to actually know the value, okay? And then all you gotta do here is you just, when you get down to here to determine which one is smaller or larger is, so sine is our Y value. So if I were to say the Y value, which is your up and down value from 1 compared to the up and down value to 3, which one is larger? 1. So sine of 1 has to be larger. Cosine of 5 versus cosine of 6. I'm gonna just erase, whoops, so sine of 1. Okay, I've got cosine of 5 versus cosine of 6. Well, notice cosine is the X value that gets us down to 5, and then cosine of 6 would be the X value that gets us out to 6. So is it further to go out to 5 and then down, or is it further to get all the way out to 6? The 6, so cosine of 6, because remember, we're talking about the X value. And then tangent of 1 versus tangent of 5. So here is 1, here is 5. Big thing that you got to think about is your positives and negatives like you did on the last example. What's true about our X and Y value for sine of 1? Positive over positive. What about down here? It's going to be negative over a positive, and so therefore, which one's greater? A positive or a negative answer? Positive, so therefore it's tangent of 1. Okay? Questions?